Excel, I'm going to do a demo for your equilibrium beaker kitchen lab experiment that we're going to do at home, okay? So I did not leave you any directions about the setup of this lab. You're going to watch them in this video because it's just easier that way, okay? So right now I've got 2 containers in front of me, all right? You can use hopefully 2 containers that are the same size, all right, would be preferable. If you don't have 2 containers that are the same size, that's okay too. The most important thing is you really do need to be able to see through them, because you guys are going to be taking some pictures of them, and we need to be able to tell how much water is in each of your containers, okay? So right now I have water in my container labeled reactants, okay? Hopefully you can read that. All right, so we have our reactants beaker, okay? And over here we have the products one. You can see the products one is currently empty because when you're trying to do a reaction, you start with reactants, you haven't made any products yet. All right, I also have 2, I just wrote scoopers on your handout, all right, if you have measuring cups. I think they work best, all right, but you can use other things as well. The important thing here is that these are different sizes, all right? Right now I have 1 cup and half a cup. You do not need to use a 1 cup and a half a cup, but they do need to be different sizes from one another. One of these is going to represent enthalpy, driving the reaction in one direction. The other one will represent entropy, driving your reaction in the other direction, okay? Just like those 2 driving forces that you have learned about. All right, so I'm going to use this one, all right, as enthalpy. Doesn't really matter, all right, as enthalpy, and it's going to drive the reaction forward. All right, right now entropy has nothing to work with. There's nothing in here, so I'm just going to kind of mind that. I can't scoop any products here, but I'm going to try to scoop this as full as I can without having to like tilt this, okay? You may want a helper, right, where one of you is scooping in one direction and the other person's going in the other direction. All right, and I'm just going to transfer that over here. I don't have anything to pour this way. All right, now as soon as we've made some products, a normal reaction would just keep taking the reactants, putting it into products, but this is a reversible reaction. We're trying to establish an equilibrium out of this. So our entropy, chaos, right, is going to scoop some of the products. Didn't get very much in there, but I got as much as I could. All right, and now we have the reaction being driven forward and reverse, okay? So we're going to keep going with this scoop, pour, scoop, pour. All right, what's important is that you scoop at the same time, all right, and you pour at the same time. Okay, so again, if you need a helper, if you're not that coordinated, that's totally fine. All right, and you're going to keep doing that until you've reached 2 different points. All right, in your lab handout, point 1, it asks you to pause when you reach a point that looks like maybe it's equilibrium. It's not. All right, that's important. You're going to keep going after that. All right, but you reach a point where you go, I bet most people think that's equilibrium. You take a picture, all right, answer a couple questions, and then you're going to keep going with the scooping. All right, once you reach what you think might be the new equilibrium, you're going to keep that going for at least another 1 to 2 minutes to really make sure, like, yes, this is equilibrium. You're going to answer some questions on your lab handout, okay? If you've got any questions, email me or pop by one of the discussions on Wednesday or Thursday, and I'll talk to you later.